Now my dear students, today we are starting the D and F block elements in this crash course. My dear students, I hope you learned all the concept in D and F block elements in theoretical part. Now we can take all the questions with concept and according to that concept and revision of the reactions. Now my dear students, we can take all questions which are asked in NEET exams. Now my dear students, we can see here question number 1, that is NEET 2003. My dear students, we can see here the scandium is a transition element but zinc is not, because this is the question, why this zinc is not a transition element but scandium is. Now my dear students, answer is both scandium and zinc ions are colorless and form white compounds. B, in case of scandium 3d orbitals are partially filled, but in zinc these are filled. Now we can see here C, last electron is assumed to be added to 4s orbitals in case of zinc, and both scandium and zinc do not exhibit variable oxidation state. Option is D. Now my dear students, concept is this, why these D block elements are called transition elements, or you can say D block elements are called transition elements. Concept is this, my dear students, transition elements have variable valency. My dear students, we can see here transition elements have variable valency. So you can see here, when variable valency present in transition elements, then these are called D block element, then these are called transition elements because variable valency are there. Now here we can see in zinc. In zinc, my dear students, outermost electronic configuration 3d10, and that is 3d10 and 4s2. So my dear students, when this zinc is converted into Zn plus 2 ions and electronic configuration is 3d10 and 4s0, then my dear students, you can see here no unpaired electrons are present in 3d10 after the removal of s electrons, and all are completely filled. D orbitals are here present. So my dear students, here variable valency is not shown by this zinc metal, only one valency is shown, and that is +2. So my dear students, here you can see the zinc, all electrons are filled. Here you can see the 4s orbital here, all electrons are filled in s orbitals as well as d orbitals. So my dear students, zinc is not shown in transition elements, but it is a D block elements because all electrons are go in the d orbitals. So my dear students, you can go the answer, that is B, and in this answer we give your concept. This is a theoretical concept. Now my dear students, this question is also asked in NEET 2013. Now we can go to the question number 2. Which of the following ions has electronic configuration Ar3d6? My dear students, here concept, you can learn all the theories which are present in your 12th board or 12th book. Now we can repeat in this crash course now with the concepts. These are the theoretical concept I give you. Concept is that which of the following ions has electronic configuration Ar3d6? My dear students, here you can see the 3D series. In 3D series, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, zinc is present. Here you can see here my dear students, 21 atomic number of scandium, 22 for titanium, 23 for vanadium, 24th for chromium, 25th manganese, and here you can see the 26th iron, 27th cobalt, 28th nickel, and here my dear students, 29th is copper. Here copper is 29th, and here zinc is the 30. These are the, my dear students, these are the 3D series, and if you see the outermost electronic configuration, we can discuss here outermost electronic configuration of these elements. So, my dear students, scandium get 3d1 4s2 here, titanium get 3d2 4s2, vanadium you can get 3d3 4s2, here chromium. My dear students, chromium get the 3d4 4s2, but in chromium abnormal electronic configuration is present, because when 3d5 and 4s1, this is the electronic configuration present in chromium, because my dear students, this as electron go to the here D. Why? Because when this 3d5 is 5 electrons are present in d orbitals, then this d orbital is called half filled d orbitals. And my dear students, this half filled d orbitals, are more stable than d4. So, you can see here 3d5 for S1 is present. Here, my dear students, you can see here this 3d5 and 4s2 is present. Here in iron you can see 3d6 4s2, cobalt you can see in cobalt this is 3d7 and 4s2, and this is the nickel, it is called 3d8 and 4s2. And my dear students, then copper you can see here this is 3d9 and 4s2. But in copper, my dear students, when s electron go to the d orbital, then you can get the, it is called 3d10 4s1, and now zinc you can get the 3d10 and 4s2. My dear students, when in d orbitals 10 electrons are filled, these are called filled d orbitals or completely filled d orbitals. And my dear students, this completely filled d orbitals, are more stable than d9. So, you can see here these are the half filled d orbitals and completely filled d orbitals. Due to this, you can get the abnormal electronic configuration. Here, my dear students, you can see the abnormal electronic configuration. Here you can see the abnormal electronic configuration, and due to this abnormal electronic configuration, my dear students, this one here. Abnormal electronic configuration, my dear students, you can see here. This 3d5 half filled d orbitals are present and it is more stable than d4, and here you can see the 3d10 completely filled d orbitals are present, which are more stable than d9. So, as electrons are go to the d orbitals, here s electron go to the d orbitals. So, 3d5 and 3d10s are, this is the electronic configuration for chromium and copper. Now, here my dear students, question is that which of the following ions has electronic configuration Ar 3d6. Ar is the noble 18 electrons are present, that is why noble gas electronic configuration inner side. So, it is also your right argon in place of this 18. So, my dear students, you can see here 3d6 is the outermost electronic configuration. Which ions have 3d6? Here you can get the 3d1. Now, my dear students, you can see here when this scandium is converted into +2 ions or +3 ions, then you remove 2 electron of this and 1 electrons of this. So, electronic configuration is percent of 3d, scandium ion is 3d 0 and 4s0. In this way, my dear students, when you can convert into titanium plus 3 ion, then 2 electrons are removed from here and one electron is removed from here, then you can see here electronic configuration is here for 3D 1 and 4s0. In this way, my dear students, here you can see the 4 options. This is the cobalt, iron, manganese. Here you can see here from this manganese, if manganese is converted to Mn plus 3, then 2 electrons are removed from here and 1 electron is removed from here. So, you can get the 3D4, 4s0. My dear students, when this iron is converted into Fe plus 3 and remove the 2 electrons from here and 1 electron from here, then you can get the 3D5, 4s0. In this way, in cobalt, you can get the cobalt CO plus 3. Plus 3 means, my dear students, 3 electrons are removed, 2 from this and 1 from this. Because, my dear students, energy, if you know the energy of 4s orbital is lower than 3d orbitals. When you see the energy of, my dear students, 3d orbital is greater than 4s orbital. So, first of all electrons are removed from this s orbitals, then d orbitals. So, here cobalt 2 electrons are removed from this and 1 electrons are removed from this. So, you can get the electronic configuration of CO plus 3, that is 3d 6 and 4s0. Now, my dear students, cobalt plus 3 is get the here electronic configuration of 3d6, and when you can go to this nickel, nickel is in first option, nickel is converted to Ni plus 3, then, my dear students, you can get the Ni plus 3, then you can get the, this is the 3d, 2 electrons are removed from here and 1 electron is removed from here. So, you can get, my dear student, that is 3d 7 and 4s0. So, here, my dear students, here you can get the A option is nickel. Here you can see CO plus 3 is the D option present, Fe plus 3 is present in C option, and here Mn plus 3 is present in B option. So, you can see the correct answer. You can see the correct answer is D. Why, my dear students, correct answer is D? Because in D you can see here 3d6 and 4s0 are the electronic configurations present. So, my dear students, when you concept with this, first of all you write the outermost electronic configuration and then you remove the number of electrons in which how many charges are present in your options. If options you can get the 3 positive charges are present, means 3 electrons are removed from the outermost shell. When you can see here only 2 positive charges are present, then you can remove only 2 electrons from these ions. And, my dear students, these are the half filled and completely filled. D orbitals are present, 3d5, 3d10 are the half filled and completely filled, and these are more stable than D4 and D9. So, question number 2, answer is D, and this question is also asked in 2010 NEET exams. Now, my dear students, when we go to the question number 3rd, my dear students, question number 3rd is also asked in 2004. Among the following series of transition metal ions, the one where all metal ions have 3d2 electronic configurations. My dear students, here you can get the first of all electronic configuration, outermost electronic configuration. You can see the 3d series. You can here Sak, Teva, here you can write here Sak, Teva, Karamana. It is a trick I give you to remember this series, Sak, Teva, Karamana, Fico, Nikozal. In this way you can write this series, Sak, Teva, Karaman, Fico, Nikozal. Here you can see the atomic number 22, which is given in your question, 23, 24 and 25. Now my dear students, you can write the electronic configuration for titanium. Here titanium is 22, so you can write here 3d2 4s2. When this titanium is converted into this plus 1 plus 2 plus 3. Here you can see 3d2 means only d orbitals 2 electrons are present. So my dear students, you can remove these 2 electrons. So my dear students, titanium, when you remove these 2 electrons, then you can get the 3d2 outermost electronic configuration and 4s0. So titanium plus 2 is present here. You can see here titanium plus 3, no, this is not answer. Titanium plus 1, no. Titanium plus 4, no. Titanium plus 2, yes, this is answer. Because in titanium plus 2, only in one option this is present. So you cannot go to the other these ions and convert and see the electronic configuration. When you can see titanium plus 1, my dear students, when we convert this titanium plus 1. So electronic configuration of titanium plus 1 is the 3d2 4s1, because only 1 electron is removed from the s orbitals. When my dear students, you can convert this titanium plus 3, then you can see here 2 plus 1, 3 electrons are removed. So you can get here 3d1 4s0. When you can see here titanium plus 4, in titanium plus 4, my dear students, you can see all the electrons are removed from S and D. So you can see here 3d0 and 4s0 is present. In this way, my dear students, you can see here in titanium, question is that among the following series of transition metal ions, the 1 all metal ions have 3d2 electronic configuration. It is called, answer is titanium plus 2, because in titanium plus 2 you can get the 3d2. When you can see the vanadium, you can also see the vanadium. Vanadium atomic number is 23 and that is the 3d3, 4s2 is the electronic configuration. And when this vanadium is converted into vanadium plus 3, my dear students, here 2 electrons are removed here and 1 here. That is why it is converted to 3d2 and 4s0. So you can get here 3d2 electrons. So you can see all these elements or ions have d2 electronic configuration. So my dear students, answer is D, and this question is also come in NEET exam 2004, and this is my dear students concept of this question. Here my dear students, first of all you can learn the electronic configuration which is given by my question number 1. I give you all the electronic and outermost electronic configuration of these elements, and this is applied now in all coming questions. Now my dear students, you can also learn in the by this trick. I can give you trick the learn to these elements sakateva sakateva CR kara MN man sakateva karamana phiko ni ko zal. This is the trick to learn these all elements. These are the 10 elements, and you can get the electronic atomic number as well as electronic configuration. Now my dear students, we can go to the question number 4. Here we can see the question number 4, which of the following configuration is correct for iron. Here my dear students, atomic number of iron, concept of this question is that atomic number of iron, first of all you can see the 26, because sakateva kar man phi 26, 21, 22, 23, 24, 25, 26. That is why my dear students, it is a 26. So you can write here electronic configuration of this compound 3d6 and 4s2. So 3d6 and 4s2 is the outermost electronic configuration. You can see here d7 and s2, this is not. Here you can see d5 and s2, it is not. B option is not correct, it is correct, not correct. Here 3d5 and p6, it is not correct, and here you can see the outermost electronic configuration is 3d6 and 4s2. So my dear student, this is the correct answer of iron electronic configuration of iron? Answer is D. When we go to the question number 5, my dear students, question number 5 we can see here, which of the following has more unpaired d electrons? First of all, what is the concept? My dear students, concept, you can write the here, first of all you can write the scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Here you can write this electronic configuration 21, 22, 23, 24, 25, 26, 27, 28, 29 and 30. You can see here this is the main thing. When you can see here iron here 26, here electronic configuration is 3d6 and 4s2, and when 2 electrons are removed from this, then you can get the 3d6 and 4s0. So my dear students, here you can see 3d6, you can fill the electrons in d orbitals 1, 2, 3, 4 and 5. My dear students, 6 electrons are filled in d orbitals here by the Hund's rule 1, 2, 3, 4, 5. First of all, my dear students, all the 5 orbitals are filled by the electrons, single electrons, and then pairing start. Then you can pair this orbital. Now remaining you have 4 unpaired electrons are present, 4 unpaired electrons are present here in this iron Fe. Because my dear students, in Fe plus 2, when you can see the Fe plus 2 electronic configuration is this one, because 2 electrons are removed from this. So you can see here 3d6 and 4s0, and here as no electron is present in s orbital, and when you can fill that these 6 electrons in d orbitals, d is divided into 5 suborbitals. So electrons are filled according to the Hund's rule. So 1 electron is filled in all d orbitals. Now we can see here 1, 2, 3, 4, 5, then pairing is start. So my dear students, you can see here 4 unpaired electrons are present in this Fe plus 2. Here you can see 4 unpaired electrons are present. Now we can see here zinc, my dear students, and copper is also present here, copper and nickel. This is, my dear students, this is, I hope this is nickel, because all are transition elements, so it is a nickel. So we can see a nickel. In nickel, electronic configuration is 3d8 and 4s2, and when this nickel is converted to Ni plus 3, when this nickel is converted to Ni plus 3, my dear students, you can see here 2 and 1, 3 electrons are replaced. So you can get the 3d7, 4s0. My dear students, when d7 is filled here, means d7, 1 electron is also filled in this orbitals for the nickel. For the nickel, when you can fill in this orbitals, then you can get only 3 electrons are present, in 3 unpaired electrons are present, 1, 2, 3. So nickel you can get 3 unpaired electrons are present in d orbitals. Now my dear students, when you can see the copper 3d10 and 4s1 is the electronic configuration of copper, because as electron is go to the d orbitals, due to completely filled d orbitals is present. So my dear students, when you can see here copper plus 1 ion, so my dear students, 1 electron is removed from here. So 3d10, d orbital is completely filled here. When d orbital is completely filled, 3d10 and 4s0. So my dear students, no electrons are present here. 3d10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here 10 electrons are filled. So no unpaired electrons are present in Cu plus 2. But here Cu plus 1 is present, and when this Cu plus 1 is present means 1 electron is removed. So here 4s0, 0 electrons unpaired. Now we can see here, my dear students, zinc. When you can see the zinc, here zinc 3d10 and 4s2 electronic configuration of zinc, and when only one electron is removed, Zn plus 2, then you can see here electronic configuration is 3d10 and 4s1 because one electron is removed from 4s2 orbital. So, my dear students, here you can see the one electron is present in this s orbital. So, one you can write here one electron. Now, we can here search all the electrons, unpaired electrons are present in the ions. So, my dear students, your answer is B, because you get here B Fe plus 2, you get 4 unpaired electrons, my dear students. So, my answer is B, and you can go to the answer B, and this is the concept. Now, my dear students, we can see the question number 6. The electronic configuration of transition element is exhibited by, my dear students, outermost electronic configuration of d block elements are ns2, n minus 1, d1 to 10. Because when you can see the 3D series, you can get the 3D 1 to 10 and 4s2. When you can see the 4D series, my dear students, you can get the 4D 1 to 10 and 5s2. My dear students, when you can get the 5D series, then you can get the 5D 1 to 10 and 6s2. So, you can see here number of shell n 4, 5, 6, here n is the number of shell, and here you can see the n minus 1 means 1 electron is less, and you can get the ns to n minus 1 d1 to 10. So, here my dear students, answer is your n minus ns2 and n minus 1 d1 to 10. So, this is the correct answer, question number 6, and this question is also asked in 1996 NEET exam, my dear students. Now, we can see the question number 7. The electronic configuration of 4 elements are given below. Which element does not belong to the same family as other? Here, my dear students, when outermost electronic configuration is, here concept, what is the concept? We can see the outermost electronic configuration. Outermost electronic configuration. This is the concept. We can see the outermost electronic configuration. Here, my dear students, we can see here when outermost electronic configuration ns 1 to 2, its s block elements, all elements are present in s block elements. When, my dear students, you can see here number 2, when ns2 and np 1 to 6 is present, means p orbital, s orbital is completely filled and electrons are present in 1 to 6 p orbital, then, my dear students, that element present in b block elements. When number 3rd, my dear students, when ns2 is completely filled and n minus 1 d 1 to 10 is present, it means that elements belong to d block. So, it is called d block elements. Here, my dear students, we can see here d 5 d 10 6s2 means this belongs to d orbitals here, and here this is d10 and s2 means it belongs to d orbitals. d10 is present here, d10 s2 means it also belongs to d orbitals, and here you can see the no d orbital is filled, it means d orbital is empty. So, my dear student, and p orbital is 5 electrons are present and 3s2, it means it is a ns2 np1 to 5. This type of electronic configuration is present. So, my dear students, it is a belong to p block elements here. So, these belong to p block elements, and here you can see here this belongs to d block elements. So, you can go the answer C. Question number 7. Question is that the electronic configuration of 4 elements are given below, which elements does not belong to the same family as other. So, my dear students, you can go to the question number 7, option C. Now, my dear students, we can discuss the question number 8. Here, my dear students, identify the incorrect statement. First of all, you can see the A option, chromium plus 2, D4 is stronger reducing agent than Fe plus 2, D6 in water. My dear students, stronger reducing agent are itself oxidized. It means chromium ions are converted into another Cr plus is Cr plus 7, Cr plus 8 ions. So, it may be because in chromium, when you can see the chromium, what is the atomic number of chromium? Sak, T, Ba, Kar, Man, Phi, Ko, Ni, Sak, scandium, titanium, beryllium, chromium. Means, my dear students, it is a 24th atomic number. You can see a 24th atomic number. So, you can see a 3D4, 4S2 is present. And when this chromium is converted into this Cr plus 2, then you can see here, my dear students, 3D4 and 4S0, outermost electronic configuration is present, and 3D4, 4S0 electronic configuration. So, my dear students, here this chromium get the electrons and it may be oxidized to chromium and remove these electrons, chromium to here 3D plus 3, as well as these electrons are removed and it is oxidized to Cr plus 4. So, my dear students, chromium is act as stronger reducing agent than Fe plus 2, D6 in water, because here as electrons removed, but D6 is more stable than D4. So, my dear students, small energy is required for this Cr plus 2, small energy is required for Cr plus 2 to remove electrons than Fe plus 2, because D4 and here D6 is more stable than D4. So, energy is large required for removal of the electrons and then it is oxidized. What is the oxidation or oxidized, my dear students? When oxidation number is increases, it is called oxidized. Stronger reducing agent are reduce the another element, but itself oxidized. So, my dear students, this is the correct answer, but here incorrect statement he want. Number B option, the transition metal and their compounds are known for their catalytic activity. Yes, due to their ability to adopt multiple oxidation states. Yes, this is answer, and to form complexes. Yes, this is also an answer. So, my dear students, it is a correct statement, but here question is not incorrect statement, and this question is also asked in NEET 2020. Interstitial compounds are those that are formed when small atoms like hydrogen, carbon, nitrogen are trapped inside the crystal lattice of metals. My dear students, this is also a correct answer. So, because these are the smallest element and these are present in the interstitial or space in atoms, space which are present between the atoms. Now, my dear students, we can go to the answer D. The oxidation state of chromium in CrO4 minus 2 and Cr2O7 minus 2 are not the same. My dear students, you can calculate the oxidation state CrO4 minus 2. Here X minus 8 is equal to minus 2. Then you can calculate this is the X is equal to plus 6. Now, we can calculate the oxidation state of Cr2O7 minus 2. Here this is a 2x minus 14 is equal to minus 2. So, my dear students, 2x is equal to 14 minus 2, that is 14 minus 2. So, it is at 12, then 2x is equal to 12, then x is equal to 12 by 2, that is equal to plus 6. So, my dear students, oxidation state is same, but here this statement is oxidation state is not same. So, my dear student, it is a incorrect statement. So, you can go in question number 8, answer is D. Now, my dear students, question number 9, the calculate spin only magnetic moment of Cr plus 2 ions in. This question is also asked in NEET 2020. What is the concept? Here, my dear students, we can calculate that the spin only magnetic moment mu is equal to root n plus 2. In this way you can calculate the magnetic moment by this formula. Here my dear students, mu is equal to magnetic moment, mu is equal to magnetic moment, and here n is equal to number of unpaired electrons. Here S is equal to number of unpaired electrons. Here my dear students, you can see here mu is equal to magnetic moment and n is equal to number of unpaired electrons. So my dear students, if number of unpaired electrons you can calculate it by this chromium. Now my dear students, what is the atomic number of chromium? Scandium, Sc, T, B, Car. Scandium, titanium, vanadium, chromium. So my dear students, atomic number is 24, 3d4, 4s2 here present. Here my dear students, when this chromium is converted to Cr plus 2, then 2 electrons are removed from here and you can get the electronic configuration is 3d4, 4s0. Here my dear students, d4 means when you fill the electrons in d orbitals, you can say here 1, 2, 3, 4 and 5. D orbitals divided into 5 parts: dxy, dyz, dxz, dx square y square, and this is called dz square. Here my dear students, we can see here d orbitals divided into 5 sub orbitals. Now we can fill the electrons d4 in these orbitals. You can fill the 1, 2, 3, 4. Here you can see the number of total unpaired electrons equal to 4, and when unpaired electrons equal to 4, then you can calculate the magnetic moment, that is 4.90. You can see here direct you can get the answer 4.90. It is a trick. I give you small trick. When you can get the number of unpaired electrons, then unpaired electrons magnetic moment is between the 4 to 5. Means you can see options. If option is 3.87, no. 5.92, it's a greater than 4. Here 2.84, it's a less than 4. That's why answer is 4.90. You can, my dear students, also calculate this by this formula. This 4 plus 2, that equal to 4 plus 2 is equal to 6, and you can get the 6 multiplied 4, that is root 24, and when you can get the root 24, and root 24 is that equal to 4.90, and Bm is Bohr magneton. So you can write, when you can calculate, you can get same numbers which are given in option B. So my dear students, we go to the question number 10. Here same concept here which is applied in earlier questions. First of all, you can write here electronic configuration, and after electronic configuration you can see the number of unpaired electrons. My dear students, when we see this chromium 24th, first of all we can see the 24th, these are 3d4 and 4s2 electronic configuration of this chromium. My dear students, when this chromium 3 electrons are replaced, 2 and 1, then you can get the 3d3 and 4s0. So my dear students, here 3d3 means 3 unpaired electrons are present in d orbitals, 1, 2, 3, 4 and 5, and 3 electrons are present in d orbitals, and these are unpaired electrons. So my dear students, you can see here unpaired electrons is equal to 3, n is equal to 3. When you see the magnetic moment formula n plus 2, then you can write here root, then my dear students, you can write here root 3 plus 2. You can see here, calculate this, 3 plus 2 is the 5 multiplied by 3, that is the root 15. So you can see here root 15 is the option of this chromium plus 3, and your root 15 is present in fifth. So B is attached with this fifth. Here B, you can see here B, and here fifth is a fifth, A, B. No, it's a D, and we can see B. Here B, my dear friends, B here fifth, means fifth is present with B, option A, and you can also get the option B. Now we can see option A, because in option A both are different options. So if you can get this different option, then you cannot calculate the C and D option. We go the A option, cobalt. First of all, you can write here electronic configuration of cobalt. Sakti ba kar man phi ko, cobalt. 6 and 7 means you can get the 27 atomic number, and this is called 3d7 4s2. Now my dear students, when you can see here cobalt is present in +3 oxidation state here. So 3 electrons are removed, 2 from s orbitals and 1 from this d orbitals. So my dear students, for cobalt +3, you can see here 3d6 4s0 is present. Now my dear students, here d orbitals 6 electrons are present, 1, 2, 3, 4. Here 1 electron, 6 electrons are present, 1, 2, 3, 4, 5 and 6. So you can get here number of unpaired electrons, n is equal to, here n is equal to 4. When here n is equal to 4 means 4 unpaired electrons are present. So my dear students, you can get the answer mu is equal to root n plus 2. Here my dear students, here n is equal to 4, 4 plus 2. So you can calculate here mu is equal to root 4, 4 plus 2, then mu is equal to 4 to the 8, and 8 multiplied by this 3, you can get root 32. So my dear students, this is the magnetic moment is equal to root 32 when n is equal to 4. So A option, CO plus 3 go to the root 32. It's a 4 plus 6, it's not 8, here 4 plus 6. So 6 is multiplied 4, you can write here 26, yes 24. You can write here this is root 24. So my dear students, you can write here this is root 24, you can get here, and this root 24 is go to this, A go to the fourth number, because in fourth you can get the root 24 Bohr magneton. Now A is attached with this 4, means your answer is A. Question number 10, my dear students, you can get the answer A. Now we can, and this question is also come in NEET 2018, and you can solve in this way. This is the concept of questions. First you can write the electronic configuration, then you can get the number of unpaired electrons, and then you can put this formula of magnetic moment. Here n is the number of unpaired electrons, here you can see and this is the formula.